Hello again, and welcome to Full Tech Ahead. I'm your host, Amanda Razani, and I'm excited to be here today with Mat Gilbert. He is the Director of AI and Data at Synapse. How are you doing?
Sure, it's great to be here.
Happy to have you on the show. Can you share a little bit about your background and what do you do over there at Synapse?
Sure. So I lead AI and data at Synapse Product Development. Simply put, Synapse is the product development firm that builds the things that you and I are going to be using tomorrow. So Synapse partners with some of the world's most innovative companies to really design and engineer their most complex hardware products. That's all the way from concept through to reality. My job specifically is to make those products intelligent. So my team builds the AI and the data systems that allow a physical device to understand and respond to its environment and anything inside that environment. So I really get to work at the bleeding edge of where physical hardware meets algorithms, and it's great to be here today.
Wonderful. Well, our topic for today is the next evolution of agentic AI, going from not just digital, but directly embedded into physical products and machines and the future of work. So, share a little bit about where are we? What are some of the physical products that we're going to see AI, agentic AI in?
Absolutely, yeah. When we talk about physical AI, I like to think of it as the third wave of AI, really. If we think looking backwards slightly, we have the first wave being kind of perception AI. So around a decade ago, we really started giving machines the ability to see and to hear. The second wave of AI has really been generative AI, which is where we've all been talking about it for the last couple of years, and that's really teaching a machine to create new content, be that new text, new audio, new video. Then we've got this third wave. I would argue that it's here now, but it's definitely coming, and that's physical AI. So this is really where the intelligence learns to act. So this is about building AI systems that perceive the world through sensors, really reason about what it's seeing, and then takes direct physical action in the world. So you can think of it kind of like taking moving from a chatbot that can perhaps book a hotel room through to a really intelligent hotel room that can adapt to a guest's needs in real time. So we're seeing applications already kind of more in the industrial space. Kind of the first real deployments of physical AI have been kind of behind the walls of distribution centers and logistics type applications. But I think we're going to start seeing them push more into kind of consumer facing applications. So think things like last mile delivery drones, sidewalk robotics, those kinds of things are all instantiations and deployments of physical AI. And then a little bit further down the line, I think we'll start to see them coming into our homes. But I think kind of home and consumer products is really the last frontier for physical AI because our homes are so kind of messy and unstructured relative to kind of the semi-structured environment of a warehouse or a factory, as an example.
Right. Also, and I would imagine that cost would be a factor as well, that there's a place, more places for businesses where they can afford the cost of these things at the moment.
For sure, yeah, and I think cost is an interesting one. I think it's one of the few things that are driving physical AI forward and is making it more accessible to us all. So you look at kind of just the costs of hardware, things like LiDAR sensors, which are often used as kind of the eyes of robotic systems and autonomous systems. They've really come down a lot in price over the last few years. Things like you need good battery packs if you've got a mobile robotic system or an automatic system. These prices have also come down. So you've got hardware costs really coming down, which is making these things more accessible. And then that's kind of combined with the rise of foundation models for robotics. So you have companies like NVIDIA putting out Groot. You have physical intelligence with their Pi Zero series of models. And these really act as the brain of the robots. And they're becoming more accessible for everybody to use and everybody to deploy. Uh, and that also is enabled by the rise of kind of really good simulation and digital twin tools. So we can now train a robot for millions of cycles in a really physically accurate virtual world before it ever really touches the real world. And again, that's making these things more accessible. It's making the technology easier and more affordable to develop before we think about deploying it.
Where are we? One of the things I think about when it comes to AI embedded in physical products and robots, I think of the humanoid robots, and I know some companies are working on those, but where are we realistically speaking when it comes to humanoid robots and what is the place for them?
Yeah, I think humanoids, if we believe everything we read, 2026, I think is is could be the year of the humanoid. I think humanoids are a really interesting challenge, and again, some of it comes down to the environments that we want to deploy humans into. But there's a few large companies that are all making kind of different strategic bets on what they think the bottleneck to scaling humanoid robotics is, and how to best kind of unblock them. So you have companies like Boston Dynamics as an example. They've spent multiple decades at this point really focusing on dynamic motion and balance. So they've really made this bet that mastering like complex physical agility, like building a robot that can do a backflip is really hard. And they've made the bet that is kind of the hardest problem. You compare that to the approach of a company like Tesla. They're kind of taking an AI first approach so that they're using all of the huge amounts of data that they've collected from their cars and the AI stack that runs in their cars. And they're using that to develop kind of general intelligence first. And then once their theory is once they've got that brain, they can deploy it into their Optimus robot. And then you have companies like Figure AI, who I think are doing really interesting things. So they are really laser focused on designing a robot for mass production from day one. So they've partnered with OpenAI for kind of the brains of the robot. They partnered with BMW for a real world use case from day one. So their strategy is all about getting to scale and practical application first. And I think looking at these different approaches, kind of they're all converging, kind of 2026, 2027, we're going to see kind of who was right, and the winner is going to be the person, I think, the company that made kind of the right strategic bet. But it's a very exciting time from a humanoid perspective.
Awesome. So, from your experience, are there some companies you're working with that have some exciting products they're working on that you could share and kind of share the use cases?
Yeah, I unfortunately the companies that I work with, I can't share the names, but there are plenty of exciting applications. So we're seeing applications of physical AI in areas like agricultural technology. So you can think kind of how do we use autonomous systems in the fairly unstructured environment of say like a field or a growing environment, right to, as I mentioned, kind of logistics, manufacturing. That's everything from packages through to your groceries if you order groceries online. There are applications and particularly startups going after very, very kind of tight vertical slices of the sector. And if there are any of those kind of classic dull, dirty, or dangerous tasks, so in robotics, they're often the kind of tasks that we try to automate first. They're the types of things that are being automated. And there's also this real focus on safety as well right now. So as these systems become more autonomous, how do we make them safe? And that's a really kind of key pillar of any design work that we do in the space.
Yeah, speaking of safety, what are some of the added risks when you move from the digital AI and you move into these physical robotics and machines? Are there additional risks?
Yeah, I think this is one of the most kind of critical distinctions between digital and physical AI. So you think about digital AI, it pretty much operates in the world of reversible transactions. So anything that happens in the digital world, like it might have serious consequences from an organization perspective, but you can essentially reverse them. If you think kind of your chat GPT hallucinates and gives you kind of a wrong fact, it's an informational error that you can correct. That's not as true in the physical world. Actions are often irreversible. So that same hallucination in a robotic arm isn't just a wrong sentence or an incorrect fact. It's a potentially catastrophic movement of the physical device. So when you're designing autonomous systems, agentic autonomous systems that operate in the physical world, you really need safety to be this absolute foundational design principle of any physical AI system.
Okay. And this technology is moving so quickly. What do you envision, say, 2 years from now? And that's a very long time, I would say, in this space.
Absolutely. Yeah, I think 2 years down the line, it's yes, it's crystal ball gazing. I think we're going to see more mass deployed applications. I think right now, a lot of organizations are either this is their core business or we're in a pilot phase. So there's a lot of organizations that are looking at how can they pilot and test various deployments of physical AI, and how can they start to see early ROI. I think 2 years down the line, a lot of organizations will have moved out of out of that pilot phase and be looking at how do they scale? So how do they move, as an example, from one distribution center to 5 to 10 to a nationwide network of deployments. And I think we're all going to get a bit more used to seeing autonomous taxis driving on the road. There's parts of the country right now where they're kind of they're everyday sightings, or a sidewalk delivery robot. As these organizations and companies scale those offerings as well, I think it's just going to be a lot more normal that we understand and we see physical autonomous systems in our everyday lives.
I have yet to take one of those Waymo rides, but I'm planning on it soon. Have you?
Absolutely, yeah. Last time I was in San Francisco, I was down there, and it's funny how used to it you get. I think it feels very novel early on, and then like everything technology related, kind of it becomes pretty normalized. It's like, oh, this just works. This is great, and you can carry on. And I think we'll see that in more and more of the space. I think another good example there is home vacuum cleaners. So something like a Roomba. You think about they were the height of novelty a decade ago, at least for myself. And they were essentially fairly unsophisticated devices that long ago. Now they will do object detection. They can drive around. If you're in my house, they can drive around the kids' toys rather than sucking them all up and getting tangled up. And they really do more detailed mapping of your environment, and they understand a lot more about the environment that they're operating in. And I think that's going to be true right across the board. We're going to see more in agricultural fields. We're going to see more out in our cities. We're going to get quite used to our deliveries arriving by drone rather than by truck as they are today.
Awesome. Well, if there was one key takeaway you could leave our audience with today, what would that be?
Yeah, I think that the key observation I made this year is this is happening now. I think when you think kind of about autonomous systems, particularly when you think about humanoids, it feels like science fiction. It's like something from the Jetsons when we were kids. Whereas what the reality is, these things are happening today. They're being deployed at scale, and we really need to be thinking about how we're building these systems, how they're going to optimize and increase the efficiency of our lives, make our lives safer. But how do we design these systems to be good to work alongside? So um, I think understanding that these are happening, it's happening right now, it's happening today, and it's an exciting time.
All right. Thank you so much. It really is. I appreciate you coming on the show and sharing your insights and some of these interesting use cases.
It's my pleasure. Thanks for the great conversation.
All right. And thank you to our audience. Stay tuned and share with us in the comments what you find most interesting and what you think the future will look like. Have a great day.